Wi-Fi is everywhere, which means weak Wi-Fi security is everywhere too. And that's exactly what we're going to fix today. Welcome to Lesson 51 of the Networking Mastery Curriculum, where we dig into Wi-Fi security and enterprise authentication. Over the next few slides, we'll work through WPA2 and WPA3, the 802.1x framework, and the Radius servers that make secure Wi-Fi possible at scale. Here's the roadmap for the next 20 minutes or so. We'll start by tracing how Wi-Fi security actually evolved, from the broken WEP standard through WPA, WPA2, and finally WPA3, because understanding the failures explains today's design choices. Then we'll compare pre-shared key with enterprise mode so you know which fits which deployment. Dive into 802.1x with Radius for proper enterprise authentication, and finish with the real-world attacks you need to defend against, plus the hardening steps that actually work. Let's start with that evolution, because the pattern here is genuinely sobering. WEP fell in minutes. Back in 2001, WPA was always meant as a stopgap, and even WPA2, the standard most networks still run today, was cracked by the crack attack on its four-way handshake in 2017. WPA3 is where you want to land. AES GCMP 256 with a say for the handshake. And for guest networks, don't leave them open. Use Enhanced Open with OWE, which encrypts traffic even without a password. Once you've picked your protocol, the next decision is how clients actually prove who they are. And both WPA2 and WPA3 give you two flavors. Personal mode, or PSK, uses one shared password for everyone. Dead simple, works on any access point. Perfect for your home or a coffee shop. But the moment someone leaves, you're rotating that key for every device. And a captured handshake can be brute forced offline. Enterprise mode, 802.1x, flips that model. Each user authenticates with their own credentials against a Radius server tied to Active Directory or LDAP. More moving parts? Yes, but you can revoke one user without disturbing anyone else. That's why corporate offices, universities, and hotels run enterprise. And why you should too, once scale demands it. So let's actually walk through how 802.1x works on the wire. You've got three players: the supplicant, which is the client device, the authenticator, which is your AP or switch acting as a gatekeeper, and the authentication server, almost always Radius. When a client first associates, the port is locked. Only eAPL frames pass. The AP requests identity, wraps the response in a Radius access request, and the server challenges back using an EAP method like PEEP or EAP TLS. Once the client proves itself against AD or L, Radius returns an access accept along with keying material, and only then does the port unlock for real traffic. Now, I mentioned EAP methods like PEEP and EAP TLS. Let's unpack what those actually are. EAP is just a framework. The real security depends on which variant you pick. Skip EAP MD5 and Leap entirely. They're broken and offer no server authentication, meaning a rogue Radius can harvest credentials. PEEP and EAP TLS wrap inner auth inside a TLS tunnel, which is solid and what most Windows AD shops run, but the gold standard is EAP TLS, mutual certificate authentication, no passwords on the wire. The catch? You need a working PKI to issue and revoke client certs at scale. Once authentication succeeds, whether by PSK or EAP, both sides still need session keys, and that's where the four-way handshake comes in. The AP sends a random nonce. The client replies with its own nonce plus a message integrity code. The AP delivers the group key for broadcast traffic, and the client acknowledges. From those nonces plus the shared PMK, both ends independently derive the same pairwise transient key. The password itself never crosses the air. But here's the catch. If an attacker captures this handshake and later cracks the PMK, they can derive the PTK and decrypt the whole session offline. That offline cracking weakness is exactly what WPA3 set out to kill. SAE, simultaneous authentication of equals, replaces the old handshake with the Dragonfly exchange, so a captured trace gives an attacker nothing to brute force. On top of that, Every session gets its own keys via ECDHE, meaning forward secrecy. Even if the password leaks tomorrow, yesterday's traffic stays sealed. WPA3 also bumps encryption to AES GCMP 256, makes management frame protection mandatory to shut down DoS attacks, and adds OBOE for encrypted open hotspots plus Easy Connect for painless IoT onboarding via QR codes. Now that you know what WPA3 defends against, let's look at the attacks themselves. An evil twin clones your SSID to harvest traffic, defeated by certificate-validated 802.1x. DoS floods kick clients off to grab handshakes, which is why 802.1 bloody protected management frames matters. WPA2's offline brute force, where attackers capture the four-way handshake and run hashcat against word lists, is the big one. SAE eliminates it entirely. Crack replayed handshake messages to reset nonces, fixed by patching back in 2017. And Karma exploits clients that auto-probe for known SSIDs, so disable auto-connect to open networks. With those attacks in mind, here's your enterprise hardening checklist. 10 controls that, taken together, raise the bar dramatically. Start with WPA3 Enterprise and EAP TLS using client certificates because passwords just don't scale securely. Always validate the Radius server certificate on clients. Otherwise, a rogue AP can impersonate your network. Segment your SSIDs by purpose into separate VLANs. Enable 802.1 use a long, random Radius shared secret and kill WPS entirely. Reaver still shreds it. Finish with rogue AP monitoring through WIPS and client isolation on guest networks. Now let's talk about where Wi-Fi security actually breaks down in the field, because the checklist only matters if you avoid these classic traps. The big one is a weak pre-shared key like Company Wi-Fi 2024, scribbled on a whiteboard and known by every ex-employee. Fix it with 802.1x Enterprise, or at minimum, rotate quarterly with 15 plus random characters. Sticking with WPA2 only leaves you exposed to crack and offline brute force, so move to WPA3 with transition mode. Don't let PAP clients accept any Radius cert. Push a CA and server name validation policy. And please never put guests or IoT devices on your corporate VLAN. A smart bulb on WPA2 PSK is a foothold waiting to happen. So let's lock in the mental model before we move on. Wi-Fi has evolved through failure. WEP broke. WPA2 took a hit from crack. And WPA3 brought us SAE, protected management frames, and forward secrecy. Pre-shared keys belong at home. In the office, you want per-user identity through 802.x, where the supplicant, the access point as authenticator, and a Radius server negotiate over EAPOL. Pick EAP TLS with certificates when you can. Fall back to PEEP IMSCHAP v2 against Active Directory when you must, and always enable PMF with separate VLANs for guests and IoT. Here's your cheat sheet. Keep this one handy. Remember the timeline. WEEP from 1999 is dead. WPA was just a stopgap. A2 from 2004 ran the world until crack exposed its handshake, and WPA3 in 2018 is where you want to be with AES GCMP 256, SAE, and protected management frames. OE handles open networks, PSK is for home, and enterprise means 802.1x with Radius, supplicant, authenticator, auth server, talking EAPOL, ideally with EAP TLS certificates. And that wraps up Wi-Fi security. Next up in Lesson 52, we're stepping outside the building entirely. Leased lines, MPLS, and Metro Ethernet, the technologies that stitch networks together across cities, countries, and continents. If this lesson helped sharpen your thinking, hit subscribe over at youtube.com on Dargslan, and I'll see you in the next one.